This is a year 2 rates question. On the rate equation, question 21, October 2021. This question is about the rate of reaction, the rate of reaction is affected by changes in condition. A student carries out 2 investigations using a reaction between aqueous sodium thiosulfate ions and hydrogen plus ions. You've got the data from an investigation. In investigation 1, the student determines how the rate of reaction is affected by changes in concentration. From the results, the student concludes that the rate equation is this. Explain how the student's results support this equation. You see, if we compare equations, experiments 1 and 2, you see the concentration of H plus is the same, but the concentration of the thiosulfate ion concentration is halved. That's halved. And the rate is also halved. So what we say, because of that, is first order with respect to the thiosulfate ions. So look, when the concentration of S2O32 minus is halved, the rate is also halved. Therefore, it is first order with respect to. That's the first mark. The second mark, we're going to compare experiments. You see, in this question, to determine the effect of H plus ions, there's no experiments where the S2O32 minus is the same. So we have to make do. Let's just use experiments 2 and 3. You see, when the concentration of H plus is halved, the concentration of S2O32 minus is divided by 4 quarters. So you see, when concentration of S2O32 minus is multiplied by a quarter, and H plus concentration is halved, the rate is 60 over 15 is 4, is also times 1 over 4. That means, ladies and gentlemen, that the H plus concentration halving has had no effect, because the proportion of S2O3 to rate has the same effect. So H plus has no effect on the rate, therefore it is 0 order with okay, second mark. Moving on. Predict a possible 2-step mechanism. The first step is the rate determining step, meaning the slowest step. How do we know what's in the rate determining step? We look at the rate equation. It's S2O32 minus. S2O32 2 minus. This is in the slowest step, and what we do, we try extracting some of the products that are in the equation. What we could extract is, let's extract some sulfur. S, we've extracted one of the products, and whatever's left behind is SO3 2 minus. We can let that be the intermediate. That intermediate is then put into the fast step. Let's add our 2 H pluses here. And you see, why is H plus here? Because H plus is 0 order. It will be in the fast step. Remember, this is slow. This is fast. And let's see what we can extract. Let's extract another product, SO2. Let's extract SO2. Let's extract some water, H2O. Let's see if this works. This intermediate cancels out with this intermediate. And so you will have S2O32 minus plus 2H plus goes on to give you S plus SO2 plus H2O. Let's see if that fits to the overall equation. Yes, it does. And mark scheme also supports that. Moving on. It says from the results, the student plots a graph of K, natural log K against 1 over T. So you see, what we're using here is actually the Arrhenius equation. In the Arrhenius equation, what you've got is the following. This is the Arrhenius equation. K is equal to the the frequency factor, A, multiplied by natural log to the power of minus EA over RT. You see, when we take natural logs of this, natural log of K, when you take natural log of the right-hand side, this is split up, and this is split up, so this can be equal to natural log A, and you see the natural log of an E function, it cancels each other out. It's an inverse of it. So that will really, the minus EA over RT comes down. So that's minus EA over RT. That's what you've got. And you see, you know the equation y equals mx plus c? This is your c, this is your y. 1 over t is your x, and your m, which is the gradient, is minus EA over R. So let's work out the gradient to work out the EA value. Let's work out the gradient. Ideally, the biggest as possible. So let's take this. So that what we got here, that's minus 2.35. We want it's going down, so it's minus that. So let's do minus 4.30 minus that, which gives you 4.30 minus minus 2.35. That gives you minus, that's minus 1.95. On the x-axis, you got 3.39 minus 3.06. Whatever that answer is, times 10 to the minus 3. Don't forget about this over here. Easy to forget, and you will lose marks. Using that, let's work this out. Minus EA over R is the gradient, which will then be Y over X. 3.39 minus 3.06. 10 to the minus 3. Is it 3.39 minus 3.06, 10 to the minus 3. 0.39 times 10 to the minus 3 minus 0.06 times 10 to the minus 3. That's better. 3.3 times 10 to the minus 4. That gives us minus 5909. 5909, and that represents EA over RT. We then 5909, let's multiply that by the R value, which is 8.314. R value is the same R value that you came across in PV equals nRT. And because we're trying to get rid of that negative, let's multiply it by the minus. That gives you 49127.426. And you see, this answer is actually in joules per mole. Joules per mole. But we want it in kilojoules per mole. So we divide the whole thing by 1,000. That would give us 49.1 kilojoules per mole. One mark, and then multiplying it by minus 8.314, and then the answer. Moving on. From the graph, the student estimates the value of natural log A as minus 2. Explain what difference, what mistake the student has made. You see, by doing this, you see, it's natural log A is the c-intercept of the y-axis. The problem with this is the y-axis, the x-axis does not start at 0, it starts at 3. So that really is not the intercept of the y-axis. So we can't, that's why that's a mistake. So we can say that natural log A is an intercept at x equaling 0. That's why. Our graph starts at x equals 3.00. Is it 3.00? Yep. Times 10 to the minus 3. I think this is the last part. The student calculates the value of k in an investigation using graphs 21.2, determine the temperature at which investigation 1 was carried out. You see, our graph, the y-axis is natural log of k. Natural log of k. So what we do, we've been given the k value, which is here. And so we take the natural log of that. So natural log of 0.075 gives you. That gives you minus 2.59. And so what we do, minus 2.59, 2.59, that's 2.6, 2.7. So if we just zoom in a bit, that will be about there. And we just then read off sorry, my pen's playing up. Start again. There you go. And we just read off like so. So that will be 3.10, 3.10 times 10 to the minus 3. That is equal to 1 over t. And we then take the inverse of that, meaning 1 divided by 3.10 times 10 to the minus 3. That gives you our answer. 1 divided by. That gives us 322.58. They want it in degrees Celsius. So 322.58 minus 273. That gives us 49.6 degrees Celsius to 3 significant figures. That is the end of that question. I'll see you tomorrow.